This is the solution to question 11 of the 2009 higher level physics paper. So there's some text about different ways that we can gain heat from solar energy falling on houses or whatever. First question is, what is the maximum energy that can fall in an area of 8 meters squared in 1 hour if the solar constant is 1350 watts per meter squared? Remember, watts is the same as 1350 joules per second per meter squared. So I've got 1350 joules every second. I've got an hour of them, so that's 60 by 60 to get to an hour, and then I'm told that there's 8 square meters. Okay, so I multiply all of those and I get my total energy to be, well, that's not an equals, that's a arrow thing. The total energy is 3.9 by 10 to the 7 joules. Okay, for part B, why is the bottom of a flat plate collector blackened? It is blackened so that it absorbs as much heat energy as possible. Part C. How much energy is required to raise the temperature of 500 liters of water from 20 degrees to 50 degrees? Okay, so 500 liters is equivalent to 500 kgs because the density of water is 1 kilogram per liter. Okay, so there's our mass. So what's the question? How much energy? So energy is mc delta theta. Okay, so I have my 500 kilograms. My specific heat capacity that's given in the question is 4,200, and the change in temperature 20 to 50. So it's a change in temperature of 30 Kelvin or 30 degrees Celsius, and put them all together and you get 6.3 by 10 to the 7 joules. Okay. Part D, the liquid in a vacuum tube solar collector has a large specific latent heat of vaporization. Explain why. The high specific heat, specific latent heat, of vaporization means that a lot of energy is absorbed by the liquid when it boils, and therefore a lot of heat energy is transferred when it condenses. Okay, part E. Name the 3 ways that heat could be lost from a vacuum tube solar collector. Okay, so radiation into the air, conduction through the materials, and convection of surrounding air. I think that's probably specific enough. F. How is the sun's energy trapped in a vacuum tube solar collector? Okay, so we go back and we read about what they said. Okay, so it has silvered walls to prevent the surrounding material from absorbing excess heat, and it is surrounded by an evacuated chamber to prevent conduction or to reduce. Yeah, it's not going to be totally evacuated. You can't do that, so there's not going to be no conduction, but it's going to be small amounts of conduction. Okay, how is the sun's energy? Yeah, I've done that. That's F. So on to part G. Describe in terms of heat transfer the operation of a heat pump. How much detail do I want? 7 marks. So a couple of sentences. A heat pump. Energy is absorbed by a liquid from a warm location. And transferred to a cool location where the liquid or the gas turns back to liquid. Dumping the latent heat. Liquid evaporation is evaporating. Could be boiling, who knows. Okay, grand. And then H, I'll squeeze it in, I'd say. Give an advantage of geothermal heating system over a solar heating system. Geothermal is always on. Solar is only during daylight.